This lecture will go over the last example from section 8.5 on power series. Here is the problem where we left off. So if we look here at part A, then we can use the ratio test and set up with the n plus 1 term on top, the n term on the bottom, and absolute value. So the absolute value remains on the x. The n, however, is going off to infinity, and we know that that is going to be positive. And we're dividing, which means we're going to multiply by the reciprocal. If we simplify, then we would have an x minus 7, an absolute value, on the top, and then we would also have an n divided by n plus 1. So the x minus 7 in absolute value can come out of the limit, and if I divide by n, I would get that limit, which would ultimately equal 1, and I would have absolute value of x minus 7. If I consider the ratio test, I know that this will converge if it is less than 1. Continuing with this problem, I know it's going to converge if that is less than 1. So that would mean that x minus 7 has to be between -1 and +1. And if I add 7 to both sides, I get that x has to be between 6 and 8. Notice what I just underlined right there. From there, I can say that the radius of convergence is 1, since the absolute value of x minus 7 is equal to 1. So the only thing I have to worry about or consider is the endpoints, and I need to check both 6 and 8 to see if it converges at that point. So if x equals 6, then I would be left with this series, which simplifies like this, and I know that that converges because it is an alternating harmonic series. And then I need to consider when x is equal to 8, and I would get this, and I know that this diverges because it is the harmonic series. So then I could write my interval where I include 6 but do not include 8. So my final answer is the radius of convergence is 1, and the interval is bracket 6, 8 parentheses. Question B was this. And again, I'm going to use the ratio test and find the limit as n approaches infinity with the absolute value of the n plus 1 term on top and the n term on the bottom. And I start to simplify, and the absolute value will stay on the x's. And in this case, I'm going to simplify the x, but also write a few terms out of the factorial. Which would be 2n plus 2 times 2n plus 1 times 2n factorial. I'm writing it this way so that I can more clearly see the cancellation of the 2n factorial. And then I'm left with the absolute value of x times this limit. And when I consider this limit, 1 is being divided by a number that's getting infinitely big, which means that will be 0. And so my final answer is 0. And so I know that this will converge for all x. because it will converge for all x, I know that my radius of convergence is infinity, and my interval is negative infinity to positive infinity. Here is letter C. I notice that both of these are raised to the power of n. So I'm going to use the special case of the ratio test, which is the root test, and take the nth root of the a sub n. So using the root test, I have the limit of the nth root of all of that. And don't forget on that, sorry, got a little ahead of myself, to include the absolute value. So the n's are gone and the absolute value remains on the x. And then if I pull that absolute value of x minus 7 out, I'm left with this, which will go to infinity because the limit as n approaches infinity of n is infinity. So it won't really matter what the x minus 7 is. And so I know that this series is going to diverge as long as x minus 7 does not equal 0. And that's because if the x minus 7 was equal to 0, then our limit would be 0, which is less than 1, which would make us converge. So I need to figure out where it will diverge. Only place, it'll diverge everywhere unless it's 0. So absolute value of 7 can't be 0 would imply that x cannot be 7. So when I write my ratio, my radius of convergence, I get 0. And when I write my interval, since it only has one number, which is the number 7, I put it in braces to signify that that is the only x value that will make the series converge. Here is the last question. And again, we're going to use the ratio test. And we're going to set up the n plus 1 term on top in absolute value and the n term on the bottom in absolute value. And I simplify, leaving the absolute values on the x's, multiply by the reciprocal, and I have this. Simplifying, I get the absolute value of x on the top, I've got a 5 on the bottom, and then I have the n plus 2 and on top and the n plus 1 on the bottom. I can pull out the absolute value of x over 5, and I'm left with this limit. That limit is equal to 1. So all in all, I have absolute value of x is equal to 5. And I know that this will converge if it is less than 1. Continuing with that, I know it will converge if that is less than 1. So if I multiply by 5 and simplify, I get this. And notice since the absolute value of x is less than 5, my radius of convergence is 5. All I need to do now is check the endpoints so that I can see what my actual interval will be. So first, if x is equal to negative 5, I have this, which simplifies to that. The 5 to the n's cancel, and I'm left with this. And I know that that's going to diverge, and I could verify that using the test for divergence, and I would have the limit not existing. So now I need to check for x equal to 5. And if I plug in 5 for x, I get to this, and this will also diverge. And again, this is by the test for divergence. If you take the limit as n approaches infinity of a sub n, you would get infinity. So in this case, I know my interval will not include the 5 or the negative 5. So my final answer is that the radius of convergence is 5, and the interval is -5 to 5, not including either one. This concludes the lecture for 8.5.